All right, going to attempt another example to help try to tie all these terms together. Once again, we're looking at a graph. Hopefully you notice this green graph is proportional. We've already talked about if it hits 0, 0, it's linear, which means it goes in a straight line and it has a positive slope, that we're dealing with a proportional graph. So we know this is proportional, but let's go ahead and let's find some things out about it. One thing that I've asked you to find is the unit rate. Well, we're going to wait on the unit rate, the unit rate in just a moment. So we're going to start to go to a couple other understandings. And one of them is the constant rate of change. If it's linear, even this one over here, that hopefully you can tell this blue one is not proportional, it is linear. So it's going to have a constant rate of change just like this one is. And then we're going to give it another name when I talk about it just a little bit differently. So here's one way to find constant rate of change. You're going to subtract some points, and you do it in the form of helicopter, which of course is difference of y over difference of x. In other words, the rise up and down over the run. So that means if I want to choose these 2 points, I need to use the y's on the top. So let me do this point as 20 minus 12. Notice this y minus this y over, have to go in the same order, this x minus this x. So 5 minus 3. Well, 20 minus 12 is 8. And 5 minus 3 is 2, and we know that 8 divided by 2 is 4, or I might just leave it 4 over 1 just now so you can see it, okay? I'll do it between these 2 points as well just to check it, okay? So, constant rate of change, 12 minus 8 over 3 minus 2. This time, 12 minus 8 is 4, 3 minus 2 is 1. By the way, there's your constant rate of change, 4 over 1. Okay. That is one way of looking at it. I can also notice that that's also what we call the slope. If I'm talking about rise over run, helicopter, to get from this point to this point, you simply went up 1, 2, 3, 4, right 1. It would look like this, up 4, right 1. Between these two, you went up 1, 2, 3, 4, 5, 6, 7, 8, right 2. But remember how 8 over 2 simplified to 4 over 1. So that's another way of counting it. You can still call it the constant rate of change, but there's another name for that when you talk about it on the graph. The movement of a line, or the relationship between y over x, is also called slope. So let me use the slope to go find one more point here. If I went from 0, 0 and went up 1, 2, 3, 4, right 1, there's a special point on this line, which is 1, 4. And now I'm going to bring back that word unit rate, because if you have a proportional relationship that starts with 1 on a point, that back number is going to be your unit rate. This is 4 for every 1. 4 up for every 1 to the right. 4 up for every 1 to the right. 4 up for every 1 to the right. 1, 2, 3, 4 up for every 1 to the right. And it would continue that way. Okay? By the way, that tells me I can also write that relationship, since it's a constant variation, y equals 4x. Remember, there's your unit rate. There is your slope. We've also called it the constant of proportionality, right? The unit rate, all of those things, it's the exact same thing. Constant of variation, constant of proportionality, unit rate. And I like to call it the coefficient of x, and also the helicopter, because that is that 4 over 1 helicopter. Okay? By the way, you might notice, if we talked about this and what this really means, this means it is $4 for every item. For every one of the x, which is items, it costs $4, which is the y, right? So if I had 0 items, 0 times 4 is 0, and that's where I got that 0.00. If I bought 3 items, 3 times 4 would be 12. There's that point, 312, and we can continue with this all the way through. So let's go to the other one and check it out just a little bit. Hopefully you recognize it is not proportional, because it does not hit 0, 0. It's still linear, which means it's still going to have a constant rate of change. It's still going to have a slope. It just won't have a constant of proportionality. It won't have direct variation. All right, so let's do a couple here. 23, I'm going to use these 2 points. 23 minus 14 over, notice I went this way, so I have to go the exact same way, 6 minus 3. Well, 23 minus 14 is 9, 6 minus 3 is 3, and if I divide those, it simplifies to 3 over 1. Let me use these 2 points. All right, 14 minus 11, once again, same order, 3 minus 2, 14 minus 11 is 3, 3 minus 2 is 1, Simplified the exact same way. So some people will say, well, that's a unit rate then, and that's proportional because we ended up getting the same thing. The problem is it truly proportional? If it's truly proportional, if I go back to this one, if I divide every single point here, except 0, 0, because you can't divide by 0, 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. 20 divided by 5 is 4. Every single one, when you divide each point, is proportional, and you still get that same 4 over 1 every time. So here we're getting 3 over 1, so some people will say, well, it's proportional, but let's check it. 11 divided by 2 is 5.5, right? 14 divided by 3, that's 4 2/3. Are you seeing that? We just changed. We don't get the exact same thing. And why do we not get that exact same thing? Because this adjustment right here of up 5. All right? And so if we had those same things, if this was items and this was dollars, the problem is when I write what we thought was maybe the constant proportionality, y equals 3x, it doesn't work. Because if I had 0 items and I took it times 3, I should have $0, but I end up with $5 for 0 items, right? And I should be able to put in 2 right here and get 6, but I put in 2 and I get out 11. Why? Because there was a little bit of an addition thing here. Maybe it was a delivery fee, or maybe they bought one extra thing other than the items, but somehow we have an extra $5 charge on there because we ended up paying $5 and getting no items to start this process. And that makes it not proportional. That thing right there makes it not proportional. Notice, direct variation will not have addition or subtraction behind it. If it's not proportional and still linear, you may have some addition or subtraction right here. All right?